Swayam Prabha. Digital India. Educated India.
Okay, so welcome back, and now we will see that if man proposing Gale-Shapley algorithm is the one decided by the central authority, then women can cheat in various ways. So first we will see the simplest possible way. So again let me write down a small example which will serve us to see the strategy. So this is the same example, but I will just write it down again, or maybe I can just copy it. Okay, so okay, so let's just take the previous example that we had. Okay. So here again the green matching is the man optimal one, man optimal stable matching, and the red matching is the woman optimal stable matching. So this we had computed previously, and we will just get ahead with that. So obviously the red matching is better one for women. So is it possible for a woman to get anything better than her man optimal partner? So this is what we want to address. So for example here, for B1 is it possible to get A1, or say for B2 is it possible to get A3 in the man optimal stable matching? So for men they wanted to get something better than the man optimal partner, because that is what they were getting in a man proposing Gale-Shapley algorithm. Here women are getting the worst stable partner, their man optimal stable partner. So that is want something better than that, and in fact if they can get woman optimal stable partner, then it is the best for them. Because as we saw, just like for men it is not possible to get a better partner than the man optimal one, for women also by symmetry it is not possible to get a better partner than the woman optimal one by cheating. As far as we are going to stick to stability, this is not possible. So the best possible for women is to get a woman optimal stable partner, even if the algorithm is man proposing Gale-Shapley algorithm. So let me write down this basic question that we have. Can a woman submit a false preference list so that she gets a better partner than her man optimal partner? And again the assumption is that the algorithm is going to be a man proposing Gale-Shapley algorithm. So now suppose we allow incomplete lists. So these are the true lists which are complete, but suppose women are allowed to submit short lists. The whole idea is that here B1 shows that she is willing to accept A1, then A3, then A2 and then A4. So what if she says, I am only willing to accept A1 and no one else? So what if women, when I say women, it is one or more women, so you can as well assume that that is one woman. What if women just truncate their preference lists? So for example, if all the women here say that I am only willing to accept my first choice and nobody else, what will happen? So the preference lists of women will be just this much, the first choices of them, and accordingly the preferences of men will be trimmed. Say it again. Correct. So if all the women just restrict their preference list to their first choice, it is possible that some of them will remain unmatched. So in this case, for example, B3 will remain unmatched. So they are at a risk of being unmatched. Right? So this is not very good. So let's say this truncation is at their first choice. Okay. So if they truncate their list at their first choice, they are at the risk of being unmatched, which doesn't serve the purpose because their true list actually include everybody. So they are willing to get matched to someone rather than getting unmatched. So this is not a good strategy for them. So then because they can get unmatched, this is not good. So is there any other way they can truncate their preference lists, at the same time make sure that they get matched? So say it again, B1, B2 and B4 are giving only the first choice. B3 gives the first two choices. So instead of this one, the new truncation happens like this. Okay. So the new lists are B1 has A1, A3. Sorry, B1 doesn't have A3. B1 has A1, B2 has A3, B3 has A1, A2 and B4 has A4. And we will also assume that once they truncate their lists, the corresponding women are also deleted from the corresponding men's lists. So the lists we will assume that always symmetric. So if a woman is in a man's preference list, then the man is also in the woman's preference list. And if that is not the case, we just delete that man and woman pair from each other's list. So here for example, A2 doesn't appear in B1's list. So once this new list is formed, we will also delete B1 from A2's list and so on. Because there is no point in proposing a woman who is not willing to accept the man. So it is without loss of generality. Now what will happen if we execute a man proposing Gale-Shapley algorithm? So let's just execute and see what happens. So now A1 cannot propose B4 because B4 doesn't have A1 in her list. A1 cannot propose to B2. So A1 can only propose to B1 and then to B3. So now A1 will propose B1 and B1 will accept. Now A2 cannot propose B1, A2 cannot propose B2 either Why? Because A2 is not in B1 and B2's list anymore. Okay, so these are ruled out. Now A2 can propose B3 and B3 will also accept. And what will happen to A3? B1 is ruled out, B2 is still there. So A3 proposes to B2 and then A4 proposes B4. So this is the matching which the Gale-Shapley algorithm will give. Because it is obtained by Gale-Shapley algorithm, it is stable and every woman also gets matched. And if you look at the red circles which indicate a woman optimal stable matching, this shows that now all women are getting matched to their woman optimal partners instead of their man optimal ones. So when the man proposing algorithm was executed on the original lists, women were getting worse partners. So B1 was getting A3 and B2 was getting A1. Now they are ensuring better partners, that is A1 and A3. Right? So this is actually woman optimal stable matching in the original instance or in the true list with respect to the two lists. Right? So women have benefited just by truncating their preference lists. Okay, so when they did this truncation at just their first choice, it did not work. But now with this new truncation, they are getting a nice result, that is they are getting woman optimal partners. And this is the best they can hope for. Okay, so now we want to prove that this always works. That is, in any instance, if the preference lists are truncated at the woman optimal partners, then there will always be woman optimal stable matching, which is output by the Gale-Shapley algorithm. So this is the first strategy. Truncating preference lists. So we are discussing strategies of women. So women will truncate their lists. At their woman optimal stable partner. So will this always work? So we want to prove that this always gives woman optimal stable matching. And going back to the previous example, so what if every woman doesn't want to cheat? Maybe some women are honest and they want to give their full list, but let's say some woman cheats. So suppose B1 only keeps her list at A1. Okay, so let's just work this out before going further. Okay, so forget about these truncations now. And suppose only B1 is trying to cheat and B1 just puts her list up to A1. So these things don't appear in B1's list. Now is B1 going to remain unmatched? Okay, so this will actually be the instance that B1 deletes everybody except A1 from her list and now the Gale-Shapley algorithm is executed. So what will happen? So if you execute and see, it will still turn out that B1 now gets A1. So this is clearly A4 is going to get B4 and then A1 will go to B2, but then A3 proposes to B2 and A3 gets accepted, A1 gets rejected and now A1 goes to B1 and gets matched. And now who remains? A2. So A2 goes to B2 but gets rejected and then A2 goes to B3. So executing a man proposing algorithm on this instance where B1 has truncated her list only up to A1 actually gives us a stable matching where B1 gets her woman optimal stable partner. So how do we prove that the woman never will remain unmatched? So now from the world of complete lists we have landed up into incomplete lists. So one small question we should address before going further is, so suppose M is a stable matching in the original instance. Okay. And now some women truncate their preference lists. Now can M become unstable in the new instance? So some women truncate their lists. Can M become unstable? Yeah, so what can happen, as in the first case there was no matching at all, no complete matching or perfect matching at all. So a matching M after this truncation may not remain a matching at all because we are deleting some edges, right. So what can happen is M may not be a valid matching because of deletion of edges. So earlier for example this green matching was matching B1 to A3 and now that matching does not remain a valid matching at all because B1 A3 edge goes away because some edges are deleted. Suppose it remains a valid matching. Then can it be unstable now? Yes. So if M is a valid matching now, that means it still exists with the truncated preference list. So whatever was deleted was anyway after this current partner of that particular woman. So she cannot participate in a blocking pair because of these deletions. Right? So whatever was truncated was the last part of her list. So if she is getting something better, she cannot form a blocking pair anyway because of the deletions. So then it remains stable. Okay, so if it is still a valid matching, it is also a stable matching in this new instance. Now we want to say that if one or woman truncates their preference list at their woman optimal stable partners, then we always have the woman optimal stable matching. So first of all, if they truncate it like this, the woman optimal stable matching still remains a stable matching in the new instance. Okay. So woman optimal stable matching remains a stable matching. And of course, this matching still matches all women and hence all men. But then if this matching matches all women and all men, then by a result that we saw earlier in Meghna's talk, every stable matching matches the same set of vertices. So even if we execute a man proposing Gale-Shapley algorithm, it is not possible to get some other matching. So there is no stable matching in which a woman gets better partner than her woman optimal stable matching, and this woman optimal stable matching still exists. So there cannot be another smaller matching which leaves this woman unmatched and matches other women somewhere. So let me just note down our observations. No stable matching can give a better partner than to any woman than her woman optimal stable partner. And with the truncated lists, when I say truncated, they are truncated at woman optimal stable partners. So with truncated lists, woman optimal stable matching is still stable. So still a valid stable matching. Okay. So a man proposing Gale-Shapley algorithm has to give this particular stable matching, because for any woman, no worse man than her woman optimal stable partner now appears in her list. So she cannot get a worse partner. By the first observation, she cannot get a better partner, so she has to get the woman optimal stable partner. So as a result of these two observations, a woman who truncates her list at her woman optimal stable partner. Indeed gets her woman optimal stable partner in all stable matchings. So, does it make sense or is there any ambiguity? Yes, so whatever matching was there in the original instance which was woman optimal, now is still valid as well as stable in the new instance. Yeah, the edges have not disappeared, it has not become unstable. Yeah, so this is for the original instance. And this is in the new instance. Yes, the truncated ones. Yes. Yeah, so why will it not happen? So earlier there was a woman optimal stable matching in the original instance. It is still a valid and stable matching in the new instance. But then every stable matching matches the same set of vertices. So because this original woman optimal stable matching was matching all the women, it will also match all the women now, and hence every stable matching in this new instance should also match all the women. Okay. So once again, if you look at the before truncation, we had complete preference lists. Now that time the woman optimal stable matching was matching all women, because in complete lists everybody is matched. And after the truncation also this matching is still valid as well as stable. But then all stable matchings have the same size and they match the same set of vertices. So this particular matching matches all set of all vertices. So every stable matching should match all vertices. So whatever stable matching this new instance has, it should still match all vertices. That is, it should still match all the women. But then a woman cannot get better partner than her woman optimal one, because she has truncated her list. She can't get a worse partner because they are no longer her valid partners. So she has to get her woman optimal partner. Yes? Yes. Yes. So the other part is okay, right? If it is not a valid matching, we can't talk about it anymore. So for example, with this truncation that we were considering, the red matching is still a valid matching. The red circles still denote a valid matching. Yes. No, so now we are taking any stable matching in the original instance, right? So this red matching was also one of the stable matchings in the original instance. Has it remained a valid matching? It has. Whereas the man optimal stable matching, which was stable in the original instance, is no longer a valid matching now. No. So this is any stable matching. So either it will not remain a valid matching like the man optimal one, or it remains a valid matching. In that case, it is also stable. So in particular, because the preference lists are being truncated at the woman optimal partners, the woman optimal stable matching still remains a valid one and hence a stable one. So no matter how the Gale-Shapley algorithm works on the new instance, this matching is stable and matches everybody. So that Gale-Shapley algorithm should also match everyone. So it should also match all women. So if a woman truncates her list at her woman optimal partner, she is not at the risk of being unmatched. Because the woman optimal stable matching is still going to match her and hence every stable matching is still going to match her. And the worst she can get is anyway the woman optimal partner, because that is where her list ends, her new list ends. And well, she does not get better, but if she gets better at all, it is well and good for her. So earlier B1 was at the risk of getting A3 and she was indeed getting A3 because of man proposing GS. If she truncates her list at A1, she is not at the risk of getting A3, but she is getting A1.
Yes, that was clear. She is not at the risk of getting. How can we eliminate the risk of
Getting no one. Because all stable matchings have the same size and they match the same set of vertices. Right? So the woman optimal stable matching is a valid stable matching in the new instance. So if that matches all vertices, then every stable matching should match all vertices, even in the new instance. Right? So because of incomplete list, there is a possibility of remaining unmatched, but that is not happening because we exhibit a stable matching which matches all vertices. And because of this nice property that all stable matchings leave the same vertices unmatched, here it is empty for the woman optimal one, so it should be empty for all stable matchings. As in the set of vertices that are left unmatched should be empty, because that set is empty for the woman optimal stable matching. Is it all clear? Yes. So if every woman truncates her preference list at the woman optimal partner, this is the only stable matching possible. So the man proposing Gale-Shapley algorithm will also give the same one. But even if all women don't cheat and one woman truncates her list like that, still she will get the woman optimal stable partner. Okay. Okay. 1 minute. Huh? So let's see. So your truncation is like this. So every woman truncates her list at the first choice. Okay. No, so just 1 second. What are your new list now? B1, B2 and B4 have the whole list. Okay. 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 B2 is only A3, B1 is A1, B4 is A4. Is that right? The black line indicates your lists. Okay. So actually the proposal order should not matter, but let's see. But then we are not considering woman proposing Gale-Shapley anyway. So we want to consider man proposing, but okay, let's say we look at woman proposing one. So what will happen? You are saying that B3 proposes A1, A1 accepts. Now B1 proposes A1 and then A1 will reject B3. Right? So B1 proposes A1 and then A1 rejects B3. And then what happens? B3 has no one in the list. So B3 is actually going to remain unmatched. B2 will get matched to A3 and B4 to A4. Right? So now B3 has remained unmatched. But then B3 truncated her list before her woman optimal stable partner. B3's woman optimal stable partner was the red circled one, which was A2. So she should not have terminated her list before that. If they do that, then they can remain unmatched. But if she goes up to A2, then she will not remain unmatched. Right? So, this again illustrates that truncating before the woman optimal stable partner leaves her at the risk of getting unmatched. In fact, that will leave her unmatched because there is no stable matching which gives her a better partner than woman optimal one. So, the best women can achieve are the woman optimal partners, and that they can achieve by simply terminating their preference list at that. Yes?
Like you say, man optimal state matching is the worst for women. Is it worst for everyone individually or collectively?
So, no individual woman has a worse stable partner than the man optimal partner.
Is that the reason why the question was before the break that every woman cheating and getting a better partner does not come at the cost of other women suffering because they get this stable matching and they were initially getting the worst possible. So since it is changing, it is becoming a better.
Yes, so they cannot get worse than their man optimal partners, but there is a stronger reason which we will see later on when we see more strategies. So here clearly terminating this list is making every woman better, or at most keeping them the same, but no woman is getting worse. Right? So it is, although it looks like a competition among women to get better partners, here actually they are all benefiting. Okay. So what we have shown is that truncating preference list at woman optimal stable partners is a very good idea because that gives them the best stable partner when the man proposing Gale-Shapley algorithm is used. Now the question comes, what if such truncation is not allowed? It is very easy to disallow truncations and require that they submit a complete list. Okay, so let's go to the case where truncations are not allowed. Or in other words, what if complete lists is a requirement? Okay, now it is not very obvious that women can benefit by cheating. Okay, so actually I will use a new page for this. Okay, so now let's see what the women can do. So let me write down an example which happens to be a little slightly larger one, but it will show us several things as far as cheating of women is concerned. So this example we will use again and again, we will write it once and for all. Okay. So this is the example that we want to use, and we will see how the woman B1 can cheat. And what its consequences are. So I will not execute the Gale-Shapley algorithm because by now you very well know how to execute it. So let me just mark the man optimal and woman optimal stable matchings. There may be more, but we are really concerned about these two. So again the green one will be man optimal one, which is B2 for A1. B2 for A1, B3 for A2, B5 for A3, B4 for A4 and B1 for A5. And similarly here it is A5, A1, A2, A4 and A3. Similarly the woman optimal one, which is B1, B2, B3, B4 and B5. And here the woman optimal one is very nice, where they get all first choices. Okay. So the red ones denote woman optimal and the green circles denote man optimal. Okay, since the woman B1 is trying to cheat and now she is required to submit a complete list. So as before she cannot terminate her list at A1. So we will see what else she can do. So if we execute Gale-Shapley algorithm, which maybe I will, so that we will see what proposals the woman B1 gets. Okay, so yeah, so it should not take long time because many men are getting their first choices. So A1 gets B2, A2 proposes to B3 and she accepts, A3 proposes to B5 and B5 also accepts. Now let us say A5 proposes to B1 and B1 accepts. What will A4 do? A4 will propose to B3, but B3 has already got A2, so B3 will reject A4. Similarly, B1 will reject A4 because B1 already has A5, and B2 will also reject A4 because B1 already has A1. So then A4 has to get matched to, yeah, so A4 proposes to B1 but B1 rejects. Yeah, so A4 also proposed to B3 first, before B3 rejected. A4 proposes to B2, which also leads to only rejection. Finally, A4 gets matched to B4. Okay. So look at this execution of Gale-Shapley algorithm and see what all proposals the woman B1 has got. Okay. So this is a proposal for B1 and this is another proposal for B1. So B1 gets only two proposals, A4 and A5, and she accepts the better one of the two, which is A5, and that gives her her man optimal stable partner, which happens to be the worst stable partner that she can get. Now let us see what B1 can do by changing her preference list a bit. So since A1, A2 and A3 did not propose her, she cannot do anything about them, and she cannot make them propose her because they will go anyway according to their own list. So let us see what will happen. So this A4 is another person who proposed B1. Now instead of this list, let us get another list for B1, which looks very mysterious, let me admit, but still. So she looks at this man who was proposing her, she puts him first in her list. okay, and keeps the rest of the list as it was. Okay. So, this looks very dicey because now if she gets proposal from A4, she has to accept it and she is ending up with a worse partner than what she was getting earlier, right. So, because now she has put A4 as the first one, she will be compelled to accept his proposal over anybody else's and she will invariably end up with this. So, this is only an experiment for her. And what is this experiment for? Just to see if she gets any more proposals. So, earlier already the last men in her list were proposing her. Now, if someone else also proposes, she will do some more experiments. Okay. So, just imagine that B1 is trying to produce various preference lists to see what all she can get. And if she gets anybody other than A5, that is better for her because anyway it is going to be man optimal stable matching by man proposing Gale-Shapley. Okay. So, her goal is to get someone who is better than A5 for her and she is experimenting with different preference lists. Okay, so, with this new list, let us see what happens. So, again these people, A1 proposes B2, A2 to B3, A3 to B5. Now, A4 proposes to B3 and B3 as before rejects. What happens when A4 proposes to B1? B1 has to accept now and let us see what its consequences are. Okay, so, now who remains? A5 remains. Now, A5 proposes to B1. Earlier B1 was accepting him over A4 with the old list, but with the new list she will reject him. So, A5 proposes to B1, but now B1 rejects with this new list. So, A5 goes ahead and proposes B5. Now, B5 prefers A5 over A3. So, B5 rejects A3 now and the execution continues. So, now A3 is rejected, so A3 proposes B1 and so on. So, let's continue. Okay. So, A3 proposes B1, B1 has to reject it because according to new list she prefers A1 over A3. So, then A3 goes on to propose B4 and I think we are done, right. So, A1 is matched to B2, A2 to B3, A4 to B1, A5 to B5 and A3 to B4. So, we are done with this. So, what is the advantage that B1 had now? Looks like she is matched to a worse partner. The point to note is that now she got a better proposal. So, she now has a better proposal compared to what she was having earlier. Okay. So, earlier A3 who was better placed in her list, her true list compared to A5 and A4 was not even proposing her. With this new list, she has made A3 propose her. Okay. So, that is the information she has gained, that if she puts A4 before A5, she can make A3 propose her, who is better than A5, that is the man optimal partner she was getting. So, let us concentrate on this proposal because this will eventually lead us to her cheating strategy. Why did she get this new proposal at all? Yes? Yes, we assume that the woman who cheats is aware of others' preference lists, but that is actually not even necessary, right? I mean, where has she used the information of others' lists? So, no, so that assumption is actually not necessary. What she looked at is, in the execution of Gale-Shapley algorithm with her true preferences, A4 and A5 proposed her. So, A5 she was anyway getting, she decided to experiment with A4. So, she put A4 before anybody else. With that, of course, she has ended up with a worse partner, but this is only an experiment. right. So now she needs the knowledge of others lists, right, because otherwise she can't perform this experiment. So just to see what proposal she was getting, she did not need this knowledge, but now to perform these experiments, she needs it. Okay, so now in this experiment, she has gained the knowledge that A3 can also possibly propose her if she puts her preferences like this. So why is she getting this new proposal? Correct. So she is rejecting A5 and accepting A4. That is why A5 is going ahead and taking B5. So because A5 is going to B5, B5 is rejecting A3, and then A3 is proposing B1. Right? So this is a cascaded chain, because B1 herself rejected A5, A5 went to B5, in turn B5 rejected A3, and then A3 proposed her, who happens to be better for her. Okay. So now this information she will use to perform another experiment to see if she gets any better proposal. So now she will not even keep this list. But because A3 is now proposing her, she will put A3 before anybody else. So A3 and then the earlier list as it is A4, A1, A2, A5. And let's see where this new experiment now takes her. So let me use this space here to perform this new experiment. Okay. So A1. Okay, so now we are using this pink list of B1 to execute another Gale-Shapley algorithm. It is like B1 is executing these algorithms to see what all she can get and then how to get a better partner compared to what she was getting, that is A5. Okay, so A1 gets B2 and A2 gets B3, there is no change in this. And now A3 first gets B5, A4 gets rejected by B3. So I will not write all the rejections. A4 goes to B1 and B1 accepts for now. But now A5 proposes to B1 and B1 rejects according to this new list. So A5 goes to B5 and gets matched. A3 gets rejected and the next one in A3's list is B1. So now A3 proposes B1. Now according to new list of B1, A3 is before A4. So now B1 will reject A4 and she accepts A3, and this is where the algorithm terminates. Have I missed anybody? A4 has to again go on proposing, so finally A4 will end up with B4. Yes. So now you see that earlier when she had put A4 before anybody else, she was actually getting a worse partner. But with this new list, which is A3, A4, A1, A2, A5, she is getting a better partner, that is A3, compared to what she was getting earlier. So the current partner that she gets is this, whereas she was getting this A5 earlier. Okay, so earlier in the first place when she used this blue list, the experiment looked very dicey. But now it seems that the experiment has become fruitful and she has got a better partner. Has she got any new proposal here so that she can continue the experiment? Not quite, right? So it turns out that although she has managed to get A3, there is no way she can make A1 or A2 propose to her. Okay. So she is not achieving as good a result as she was achieving by truncating her list at A1, but at least she is getting a better partner, that is A3, compared to her earlier partner. So now she is submitting a complete list and still achieving a better partner. So any question here before I go further? See, the crucial idea here is, among the proposals that this woman receives, if she puts any one of them at the beginning of her list, she is going to get matched to him in the man optimal matching. So with her true list, she was not receiving any other proposal than A5 and A4, but with her false list, she received new proposal and she used it. Now if she had received further new proposals with this new pink list, she would have continued this experiment. But unfortunately, she does not receive a new proposal. So this list seems to be better than her true list. So any question? So even if she receives multiple new proposals in one round of this experiment, she will try putting each one of them in the beginning and keep modifying her preference list. And in all these rounds, whatever the best proposal she receives, she will just put that one in the beginning and that is all.